Good day, sir. Good day, everyone. For this video, I'm going to discuss a chapter 4, which is statistical analysis. The challenge in research is to prove observations and conclusions behind reasonable doubt. While most engineering research is numerically based and numbers are a prime outcome, some research is qualitatively based. In the later research, one common method of analysis is to convert qualitative results to the numbers and they use statistics to deduce the reliability of the outcomes and the conclusions. For these reasons, regardless of the research methodology, researchers must pay particular attention to the use of statistics and the measure of uncertainty, experimental and modeling, in their research methods and in the development of conclusions. It's expected that graduate engineers have already taken one or more courses in statistics. Engineers commonly over-specify requirements in order to ensure that reliability of the designs and production methods. Evaluations of the probability of failure, reliability calculations, and the inclusions of fail-safe designs are commonly used by practicing engineers. For these reasons, research which generates outcomes which do not anticipate failure are unlikely to be broadly acceptable to the engineering industry and its clients. As a consequence, research outcomes which do not anticipate the probability of failure are better described as scientific investigations rather than engineering research. Before you're going to choose what statistical techniques to be used on your research, you have to go back in your statement of your problem or the objectives of your research study because it preserves as your basis on what statistic techniques you are going to use in analyzing the data associated in each statement. So first, let's identify what is statistical analysis. A statistical analysis involves analyzing collected data with the aid of statistical tool to answer the research problem. Thus, this gives meaning to the data collected. This is why you have to use your research problem or your statement of the problem as basis in selecting appropriate techniques in analyzing the data that you wish to obtain based on each statement of the problem of your research study. So, these are some examples of statistical analysis: descriptive statistics, ANOVA statistics, and the t-test. Actually, this is the common statistics used by the researcher, the descriptive statistics. So this describes the relationship between variables and provides a summary of data in the form of mean, median, and mode. And also you can describe the data of under the descriptive statistics with the use of percentage frequency distribution. Another example of statistical techniques is the t-test. This is used to test the null hypothesis that there is no difference between the means of the two groups. Unfortunately, these tests cannot be used for comparison of three or more groups. So, the focus of this analysis is very applicable only if you're comparing of two groups. ANOVA statistics. This is used to test if there is any significant difference between the means of two or more groups. So, you can use analysis of variance or ANOVA in order to address to compare three or more groups. Here's an example problem, and let's try to analyze what statistical tool to be used. A bridge is designed to carry the weight of 40 vehicles. In constructing the bridge, the company might be produce a design assuming 60 vehicles in addition to the one based on 40 vehicles, and perform a cost comparison for the two scenarios. If the cost differential is small, the structures might be better built for the higher vehicle loading. In doing so, the company is covering the possibility of less than perfect material properties, the impact of aging on the load-bearing capacity, and the possibility of an extra heavy vehicle on the bridge. So, Based on the scenario, we can use a t-test because we can compare and find the difference between the two variables. This chapter investigates the concept of the appropriate level of accuracy required for research outcomes to be acceptable in human society, as the primary objective of engineering is to improvement of the human conditions. All engineering disciplines have an ethical obligations to ensure human safety. And that's all for my video. Thank you and God bless.